Okay, we're going to go over the answers to your worksheet number 1. So it should say naming alkanes worksheet number 1 at the top. You can check your own work quickly. Problems 1, 2, and 3 you can see there. I'm going to explain why the answers are what they are so that if you do have something wrong, hopefully you can understand the right way to do it. So remember that in each problem, you always want to find the longest chain of continuous carbons. So for number 1, no matter how you do this, whether you take a turn, you're going to always have a chain of 3. And so that parent chain, that becomes your parent chain. Anything hanging off of it is called a substituent. And then you want to number the parent chain so that you end up with the substituents having the lowest possible number. So if you look at that one, this substituent CH3 is called a methyl group. It lives on carbon number 2, so we call it 2-methyl propane. Propane is used because this parent chain is 3 carbons. Now, on problem number 2, when you try to find the longest continuous carbon chain, you have to be very careful. You have to make sure that you pick the right number of carbons. Don't be fooled that there are 3. There are actually 4. And it doesn't matter which 4 you pick as long as you can do it continuously. Anything that hangs off of that parent chain is considered a substituent. And you want to number your carbons so that the substituent has the lowest possible number. So this one ends up being 2-methylbutane. Butane because it's a 4-carbon parent chain. Number 3, when you look at number 3 here, if you try to find the longest parent chain, make sure that you always check that it's not always just the top chain. So if you count here 1, 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5, 6, 7, you have to take that top chain because that's the longest possible carbons. Now this group is attached to the parent. You want to number them so that this group has its lowest possible numbering system. Either way, it would be a 4. Either way you numbered it. And now that it's a 2-carbon system, that is called an ethyl group, starting with an E. So 7 carbons as a parent means it's a heptane. The ethyl living on 4 makes it 4-ethylheptane. Moving on to problems 4, 5, and 6. If you look at problem number 4, the answer is 3-ethyl-4-methylheptane. Again, your job is to find the longest continuous chain of carbons. So if you check 1, 2, 3, 4, 5, 6, 7, even if you were to turn up 1, 2, 3, 4, 5, 6, that's shorter. So you have to go with that parent chain. All of these groups that are hanging off of the parent chain get circled, and you number the parent chain so that the substituents circled have the lowest possible numbers. So you have to number it from right to left, giving the substituents the numbers 3 and 4. Now, this substituent is a methyl group because it has 1 carbon, whereas this one is the ethyl group. You have to list them alphabetically. So that's why it goes 3-ethyl, 4-methylheptane. On number 5, you want to be careful that you get your longest parent chain correct. If you go straight across the top, you'll find that it's 1, 2, 3, 4, 5, 6, 7. But if you check 1, 2, 3, 4, 5, 6, 7, 8, that's actually the longest parent chain. Anything that is not attached to your, not in the parent chain is an attachment or a substituent. Circle those. Same groups as we had before, a methyl and an ethyl. And we need to number them so that they have the lowest numbering system. So we number from left to right, giving the substituents the numbers 3 and 5. Again, you list them alphabetically. So ethyl goes first. 5-ethyl, 3-methyl, octane. Octane because there are 8 carbons in the parent chain. On number 6, the longest chain is a 10-carbon chain. If you count carefully, that's the longest one you can make without picking up your pen. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the chain. And you have quite a few substituents. Well, excuse me, it just looks like you have 2 again. So you want to number them so they have the lowest possible numbering. 1, 2, 3, 4, 5. Now both are attached to the 5. You have to list them alphabetically, and you do them separately because they are not the same group. So you say 5-ethyl, 5-methyl, decane. Dec comes from 10 carbons. And on our last problem for the front page here, you want to find the longest chain again. Make sure you do the pencil test so that you can find the longest continuous chain. And you really have to be creative here. This one actually starts way up here and snakes around like this. So if you look at this, you get a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon parent chain. The groups that are attached are here, and you want to number these so that they have the lowest possible numbering. Now, if you notice, either way you go, 1, 2, 3, this becomes a 4, or if you went 1, 2, 3, this would become a 4. So which one do you pick? Well, being that this is a methyl group over here, and that this one is an ethyl group, we're going to let the E be the determining factor for our numbering system. So E, because it goes first, will be 4, and this will be the 6. So it becomes 4-ethyl, 6-methyl, nonane. N-O-N because of the 9 carbons. So that's how you do the front page of the assignment. Now, if you want to check your own drawing, you certainly can. And I'm okay if you did a little bit of a condensed structure here. For number 8, if you have octane, oct means that there are 8 carbons. So you should have 1, 2, 3, 4, 5, 6, 7, 8. On the 4th one in, you should have an ethyl group. Remember, it doesn't matter if you draw that up or down, or if you draw both of these C's going down. The rest of the job would be to fill in the H's. Remember, each carbon can only make 4 total bonds. So that's how you determine how many H's are left over. Okay, so there's your structure for number 8. For number 9, 9 has 9 carbons. So you make 1, 2, 3, 9 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. On the second carbon in, you're going to put a methyl group. Methyl is CH3. And since that's the only other attachment, you just fill in with H's. Now, a little bit of a comment on this one. The way that this problem is typed up, it's showing a dash, and all of these are showing dashes between the name. That's technically not correct, but I would never mark you wrong. I'm not going to get worked up over commas versus dashes, but just as a note, numbers are separated with commas and words are separated with dashes, but our numbers and words, are separated with dashes. So number 10, moving on to number 10, the parent is pentane. That's 5 carbons. And you have 2 methyl groups, dimethyl. That means there are 2 of them, and they both live on carbon number 2. So you have to put 1 up and 1 down, and then fill in the rest with your H's. Okay. Next problem is pentane again. There are 5 carbons, so one more time we're going to draw a chain of 5. But on this one, the attachment is on the 3rd carbon, and this time the attachment is an ethyl group. That means there are 2 C's and 5 H's. Now, you can list those individually if you want, and then the rest is filling in H's. And then we're on to the last problem. So the next one, the last problem says heptane as a parent chain. So heptane has 7 carbons. On this one, on the 3rd carbon in, we have an ethyl group. So 1, 2, 3. Ethyl again is CH2, CH3. It doesn't matter if you draw that above the C or below the C. And on the 2nd carbon, we have a methyl group. Again, it doesn't matter if we draw it above or below. And since that's every attachment that we've dealt with, the rest is just filling in H's. So just check that you've had the right number of H's. And just kind of as a hint, when you guys take your quiz/test on this unit, if you forget your H's, I will mark them wrong. So I will remind you of that, but I just want you to get in the habit of making sure that they're not there now. So hopefully this helps you understand your homework a little better. And if you still have questions on the worksheet, when I come back to class, I can help you, or you can come in before school if that will be better for you. You will have another assignment like this that I will collect tomorrow, well, Tuesday. So good luck, and work with each other to help each other out if you need to.